Hello, class. In this video, I'd like to run through the solutions to Lab 1-4, 1-5. The first two problems ask you to identify the slope of each line. So question 1A is a little tricky. You notice the scale is a little bit different here, right? Normally we count by ones, but the y-axis, or the vertical axis, we're counting by tens. So many of you have been taught that the slope is really equal to the rise over the run, right? If I pick 2 points on the line that end up in the corner of one of these boxes, you can see that we rise 10, 20 units, and we run 1 unit, right? From left to right, we go 1 unit, but from top to bottom or bottom to top, we rise 10, 20 units over 1 unit. So the slope would be 20 over 1. Another way to think about this problem would be to pick 2 points, right? This point, again, that ends up on a corner of one of these boxes, the coordinates of this point would be 1, 30, and the coordinates of this point would be 0, 10. So I typed that out for you on a Word document. So it might look something like this, right? This point is the 1, 30 and 0, 10. And you'll remember that the slope is y2 minus y1 over x2 minus x1. So if this is x and y, we would simply do 30 minus 10 over 1 minus 0, right? Y minus y over x minus x. And you end up with 20 over 1. Oops, and I incorrectly wrote 2, but the final answer should actually be 20. So I fixed that, right? So 30 minus 10 over 1 minus 0 is 20 over 1, which reduces to 20. So that was the answer for question 1. Question 1B, well, you can look at this and you see this line's not rising and it's not falling, so we know the slope is 0. But if you didn't see that, again, you could pick 2 points, 0, 2 and 2, 2, and you could go through that exercise of y2 minus y1 over x2 minus x1, and you'd end up with 0 over 2. And anything divided by 0 is 0. You could also think about the rise over the run, right? The rise is 0, right? This line does not rise, and it does run. And it doesn't matter how many units it runs. You could run 1 unit, 2, 3, 4. The bottom line is the rise is always going to be 0, so your slope will always be 0. Again, I tell students in my class, imagine if you were walking on this line, if this line was a treadmill. Are you going up a hill or down a hill? Well, in this case, you're doing neither, so the slope is 0. I know this slope is positive because if I was walking in this direction, I'd be going up a hill. Okay, so that's the slope for the first two. Next problem. You have the enrollment at a college in the late 90s. T represents the number of years since 1995. So T equals 0 is 1995. This would be 96, 97, and so on. So the practical meaning of the point 3, 1600 would be 3 years after 1995, which would be 1998. The enrollment was 1600, right? Or there were 1600 people enrolled. Find the slope of this line. Well, think of these as 2 points, right? y2 minus y1, or 2200 minus 1600, over 5 minus 3, leaves me with 300. So the slope is 300. The practical meaning, well, each year the number of students would increase by 300, right? It's right, if y represents the number of students and x represents the years, yeah, for every year that increases, the number of students would increase by 300. Find the equation of the line. Well, we know the equation of any line is y equals mx plus b. And we know what m is. We found that. That's the slope. And we can substitute an x and a y from these 2 points. So I can either put in 3 for x and 1600 for y, or I could use the points 5 and 2200. Doesn't matter which point I use, I should end up with 700 as b. So we'd have y equals 300x plus 700, but they did ask us to use the letter n and t. So instead of y, we use n. Instead of x, we use t. Part E, use the equation to estimate the number of students enrolled in 1999. So you have to remember, 1999 is 4 years after 1995. So we're going to replace t with 4, right? Because 96, 97, 98, 99. All right, so I'll insert 4 into t, and you end up with 300 times 4 plus 700 is 1900. So in 1999, you should have 1900 students. The last two problems have you look at parallel lines. So we're given an equation, and we know that parallel lines have the same slope, but different y-intercepts or different b values. So if this is line 1, line 2 is going to look just like this, except instead of 11, we're going to have some other number. So if we write y equals mx plus b, if you were to replace the m with -3 and the y with 5 and the 0 with x, you end up with a b that equals 5. So you replace the b with 5. Okay. If you look at number 4, see, this problem's not in slope-intercept form, right? See, the problem above was in y equals mx plus b form. This equation is not, so we have to do some math. So we bring the 12x over by subtracting 12x. Then we divide everything by -2. Make sure you watch your signs. And this is our new equation, y equals 6x plus 4. So we want to find the line that's parallel to this line. Again, parallel lines have the same slope, so I know m is going to be 6. So if I write y equals mx plus b, I'm going to replace the m with 6, and I'm going to replace the x with 9, and the y with -1, and solve for b. You end up with -55. So again, parallel lines have the same slope, so if this is the first line, 6x plus 4, we know this is going to be y equals 6x plus our new b. And that should do it for this lab. If you have any questions, please send me an email, stop by office hours, come to my lectures on Tuesdays. Do not leave any question unresolved. Thanks for watching.